So good afternoon, everyone. Welcome back to Math 122. I hope you all had a restful spring break and a safe spring break. So today we're going to get back into a little bit more calculus. And for the times that I've taught this course in the spring, I'm not trying to scare anyone, but there is a fairly big divide from pre-spring break material to post-spring break material. So what we've been doing up until now is just sort of like, we spent a lot of time in chapter 1 doing review, and then we had chapter 2, which was kind of like dancing on the outside of like actual calculus, right? And then we learned the first few rules of differentiation, right? But ultimately, what we want to do with all of this differentiation stuff is use it to, analyze the world and make inferences. In this class, most of the time, those inferences are business related. So that's going to be a lot more of what we're doing moving forward, especially in chapter 4. And then chapter 5, we move on to integration. Okay, so we're finishing up today with some additional derivative rules, which going into chapter 4 are going to be sort of the basis of the groundwork for that analysis that we're going to do. So this chapter 3 stuff, memorizing these rules is totally 100% imperative. You must do it. You will not pass the class if you don't memorize the rules and know how to use them and when to use them. Again, not to scare you, we're going to learn it all together, and the homework is going to help you a lot. But just make sure that you're on top of this chapter 3 stuff, because it'll be really important going forward. So if you need a little bit of extra help, come to my office hours, go to the Math Tutoring Center, go to Jacob's SI session, raise your hand in class when you have a question, and then, well, we'll get to that in a sec. And also, when we have group work, I know some of you I don't always get to, so if I haven't gotten to you in a while, raise your hand and make sure that either Jacob or I give you some individual attention, okay? Deal? Okay, cool. All right, so that's my speech on that. So today we're going to talk about section 3.3 and 3.4, so learning the last few rules of differentiation. There were 2 homework assignments due yesterday, and there is going to be 2 homework assignments on what we learned today, and maybe on Thursday, which will be due on Monday. Your next quiz is quiz 6 this Thursday. It covers sections 2.5, 3.1, and 3.2. And my office hours are as usual, etc. So, Alex, what was your question?
There's a cheat question on chapter 3.1.
Uh-huh.
Question 14, it seems to have a little struggles with.
Okay, is this the one about the marginal cost thing?
Yeah.
Yeah, okay. Let me give a quick. I've had a lot of questions on that one, so let me give a quick description of what we do with that one. So the question, if I remember right, they give you something like C of Q equals 500 plus 3Q squared, or something like that. And they ask you, what is the marginal cost but of producing the 15th unit, or something like that, 15th unit. Okay, so the marginal cost of producing the 15th unit can be approximated by the difference between C of 15 and C of 14, right? So we take however much it costs to produce the 15 units minus how much it costs to produce 14 units. That gives us how much it costed us to produce the 15th unit, right? So what this is actually going to approximate is going to be C prime, which is the marginal cost, of 14, okay? C prime of 14. So C prime of 14 will tell us the approximate cost of the 15th item. Okay, so for this problem, what we need to do is compute C prime, which we can do easily using the power rule and the constant multiple rule, or the constant rule, which says this is going to be 6Q, right? And what we're going to do is we're going to plug in
Not to cut you off, definitely confused on this one as well.
Different question. Okay.
Yeah, I mean, I'm still lost on this one, so.
Well, yeah, this is good. So I've had a lot of students asking about this question. We need to plug in the number prior to the unit, which we are increasing to, okay? The reason is we are considering increasing production from our current production level, which our current production level is 14. That's why we use 14, not 15, for this problem. Any questions on that one? So we just plug in like how we would normally, 6 times 14, okay? Any questions on that? All right, then what's the one you were asking about?
3.1, question 14.
Okay, can you read it out for me?
Yeah, making my way on the plus right now.
Yep.
So it says find the equation of the line tangent of y equals 2x to the third, pretty long, minus 8x squared plus 3x minus 6 at x equals 2.
Okay, so this is just a tangent line problem. So we know the tangent line is given by the formula f of a plus f prime of a times x minus a. And in our problem, they tell us that a is equal to 2. So we just put in 2 for a. So we need to do f of 2 plus f prime of 2 times x minus 2. And we'll be done once we establish what these two numbers are, okay? So the first number, okay, f of 2 can be gotten by just plug in 2, okay? Plug in 2. And how about the second number? How can I figure out what is f prime of 2? Someone help me out?
You take the derivative of the function and plug it in.
Yeah, you just take the derivative of the function and plug in 2. So the way we do the derivative for this one is we use 2 rules, basically. The power rule, or 3 rules. Power rule, constant multiple rule, and also sum and difference rule. Those are the rules which we use. So to get y prime, okay, which is f prime of x, we do the derivative, which in this case we get 6x squared minus 16x plus 3, and the 6 just goes away because the derivative of a constant is 0. And then we get f prime of 2 by just plug in. Okay, plug in. From here, all we have to do is substitute these two numbers in here, and that'll give us the equation of our tangent line. Yes?
I'm confused. Since, like, in the original problem, it's to the third power, would you cube it? Or square it?
So, you're talking about when we're plugging?
Yeah. No, whenever you're, at the bottom, you write 6x squared.
Yes.
So I thought you would cube it.
So for
you
two,
just multiply it by 3?
so 2x cubed, the 3 comes down,
Okay.
and you multiply, and then you take away 1 from the power.
Oh.
So 1 less of 3 is 2. That's how we get the new power, and the constant gets multiplied by whatever was the old power. Okay? Does that clear things up?
Yeah, thank you.
So wait, what do you do with the x minus a part of the equation?
You leave it. Right? You leave it. So okay, let's go through it.
I get it.
It's okay. So let's do f of 2. So f of 2, what do we get? We get 2 to the 4, which is 16, and then we get minus 32, and then plus 6, minus 6, right? So f of 2 is minus 16, right? And then f prime of 2, when we plug in here, we get 6 times 4 is 24, minus 32, and then plus 3. So 24 minus 32 That gets us negative 8. And then we add 3 is negative 5, right? So at the end of the day, t of x, the function, the tangent line, is given by the equation negative 16 minus 5 times x minus 2. Okay, so the reason that we leave the x minus 2 here is because this is a function of x, right? This is a line. It looks like a downwards going line, which is tangent to this weird and curvy polynomial here, okay? This weird curvy polynomial. So in particular, it's still a function of x. So x is just going to hang out here because we need to still be able to plug into it. In fact, if we wanted to know, like, what is f of 2.1 or something like that, we could approximate f of 2.1 using t of 2.1, which we would get by taking this equation and plugging in 2.1 in for x, right? Does that make sense?
No, I got it.
So this is just if we wanted to approximate this. So let's make a picture really quick.
For the answer to the question, I'm not actually doing it.
No. For the answer for the actual question, you'll put in something like this, okay? Exactly. So let's see what is actually happening here. So 2x cubed minus 8x squared. So 2x cubed. And then we have minus 8x squared. And then what was it? Plus 3x. And then minus 6. Was that it? And then we got minus 16 plus, no, not plus, minus 5, and then we had x minus 2, right? Is that correct? Okay, so let's take a look here. So you can see what's going on in the following way. So where's x equals to 2? That's this vertical line, right? So we go to where the function is at for x equals 2, and we make this tangent line, this blue line, is the equation which we just derived, which tells us, okay, how tall is the tangent line for a given x value. The height of the tangent line at x equals 2 is the same as the height of the function at x equals 2, right? And it's for a short while going essentially in the same direction, right? So it's close by, going in the same direction. So if we wanted to know, like, okay, how tall is the red curve when x is equal to 1? Well, we could instead find how tall is the blue line when x is equal to 1. And you'll agree with me that it's easier to plug into the blue equation than it is to plug into the red equation, and we want to do less work. So we're just plug in 1 to the blue equation and we say, oh, there it is, it's close enough. In terms of, like, the height is very similar here and here. Okay? So that's what we are doing with tangent line approximation. So ultimately, what we're trying to do for this problem is find the equation of this blue line. You know a point that it goes through, namely 2 comma, what was it? 2 comma negative 16, and you know the slope is just the derivative of the function. So we know the slope, we know the point, we can find the equation of that line. Okay, do we feel better about this now that we've seen it drawn out like that? Okay, cool. All right, any other things that we should talk about before we go on to new material? Okay, actually, before we go on to new material, let me quickly remind you of the rules that we've learned so far, because maybe you've forgotten some of them over the break. All right. So the things we know how to do derivatives of so far are numbers. The derivative of a number is just 0. Derivative of a linear function, okay, so something like mx plus b, is just the slope of that linear function. And we also learned that the derivative of a sum is just the sum of the derivatives. And the derivative of a constant times a function is just a constant times the derivative of that function. Okay, so those were the most basic rules of how to do derivatives of, like, lines, basically. And then we learned some more ones. So we learned the power rule. So the derivative of x to the n, okay? The derivative of x to the n, you just take the power down as a constant multiple, and then you make the power one less, okay? So something like x to the 8 becomes 8x to the 7th, okay? And the other rules we learned were derivative of a to the x, okay? So the derivative of a to the x, so a is just a number, is going to be a to the x again, but times ln of a, okay? Times ln of a. And the derivative of e to the kx is just k times e to the kx, okay? So you just multiply by that power there, okay? And finally, we learned that the derivative of the natural log function is 1 over x. So these are the rules that we've learned so far. Any questions about any of the ones we've learned so far before we pile on some more? Yeah?
You should go over right after the linear functions, what the derivative of that.
You're talking about the power rule, n times x to the...
Yeah.
This one?
Yeah.
Okay, so...
I just needed to see it through.
Yeah, so derivative of x to the n. So in this case, x is just a variable, and n here is a number, okay? N here is a number. So think any of these examples down here, like, okay, x to the 4.5, right? X to the 4.5. Let's do that one. So to get that derivative, we just bring the power down. We know the constant multiple rule says the 2 is going to hang out, and then what I need to write in this blank is just the derivative of x to the 4.5, which we just multiply the power down, and then x, and then the power should be 1 less than it was before. So take away 1 from 4.5, we get 3.5. So altogether, this would be 9x to the 3.5. All right. Any other questions before we move on to new stuff? All right, I know it's a lot of rules all at once, okay? And it's a lot of new information to take in. So I just want to reiterate, these are things that you're not going to be able to get around memorizing. So it might be worthwhile to write them down on some flashcards, test yourself once a day, and just get them down so that you can pull them out when it comes time for the quiz or test. Okay? Yeah, Andon.
You mind doing an example of like a constant times a function?
Sure. So that's kind of like what we just did here. So 2 is a constant, right? So the way that you look at it is you look at it as 2 times x to the 4.5. Using this rule, okay, I know how to do the derivative of this piece, right? So what I mean by the constant multiple rule is that this 2 here is just going to hang out, okay? So the derivative of all of this stuff, okay, derivative of that is 2 times whatever is the derivative of x to the 4.5. So what I mean by the constant multiple rule here is the fact that this 2 can come out. All right? Does that answer your question?
Yes, sir.
Okay.
What about there's a pi?
You mean like this one down here?
Yeah.
So for this one, we have to remember that what is pi ultimately? It's a number, right? Pi is a number. So if I have x to a number, I know how to do the derivative of that. How do I do the derivative of x to a number? I multiply by the old power. And what happens to my new power?
This one.
It should be 1 less than it was before. 1 less than pi. There's a neat way of writing it. You just write pi minus 1. Okay? Or so it's something like 2.14159. Okay? Instead of 3.14159. that answer your question? Okay, cool. So that's a comprehensive review of the power rule. Let's go down to these rules here. Are there any questions on these ones? Derivatives of exponential functions or logarithms. Should we just do some examples?
Yes.
Okay. Why don't we do some examples? That's fine. Okay. Let's start with this one, C, part C. Okay, so the sum rule says I can just do the derivative of each one of these pieces and just write them down and then keep the pluses in between. So the first one becomes 16x by the power rule. Now plus. The 8 by the constant multiple rule is going to hang out, and then I need to multiply by the derivative of e to the x. What is the derivative of e to the x? It's just e to the x again. Okay? If you want, you can apply the e to the kx rule, where k is 1. So we would get 1 times e to the 1x, which is just e to the x. Okay, now for the next part. Again, because of the constant multiple rule, the 8 is going to hang out, and now I need to multiply by whatever is the derivative of 4 to the x, right? Which the derivative of 4 to the x by the a to the x rule is 4 to the x times ln of 4. All done. Any questions on this example? Yeah.
Is there ever a time where you need to multiply the 8 times the 4 the x?
Well, so the question, are you asking, can we combine these two, basically?
Yes.
Well, we actually can't, right? Because if you were to put parentheses around this thing, right, like this, so 4 is what's being raised to the x power. So x is 1, 2, 3, 4. We're talking about 8 times 4 squared, 8 times 4 cubed, 8 times 5 cubed. If I were to instead combine them, it would be as if I was putting a parentheses here, which is not the same thing because that x power would distribute over each of these. So we actually can't combine like that. We have to leave it like so, okay? Does that answer your question?
Yeah.
Any more questions on this one? Yeah.
Maybe dumb, but why do you multiply by ln of 4?
It's not dumb. It's confusing. So it really just comes from the rule. I see 4 to the x, okay? And in my brain, I think back on all of the rules, and I look for the one that looks like it applies to my current situation. My current situation is I have a number being raised to the x power. The rule, which I see in here, which applies for that, is a to the x, where a is a number, right? And the rule says that the derivative of a to the x is going to be just a to the x times ln of that number. So since I just identify 4 to the x as being applicable for this rule, and so I follow the rule and I just write it down. There are like reasons behind these things, but we don't really go deep into the theory in this class. We just learn the rules and how to use them to make inferences, right? If you want to talk more about like the reasons behind the rules, you can come to office hours. Okay. Let's do one with ln. Like, I don't know. Let's do this one. Okay, 5t cubed plus 16t minus 2 plus 2 ln t. All right, this is no problem. I know that because of the sum rule, I just write down the derivative of each of these things and then add them together or subtract them as normal. So the first one becomes 15t squared by the power rule, and the second one becomes 16 by the linear function rule, or the power rule if you want. You can think of this as 16 times 1 times t to the 0, which is just 16, right? So there's 16. And then what happens to minus 2? Just 0, so I'm not going to write anything. And then how about this last part? What does it become? Plus 2 over t. Okay, so the 2 hangs out, and the derivative of ln of t is 1 over t, so 2 times 1 over t is 2 over t. All right, we happy with that one now? Any questions on that one? Yeah, so again, broadly speaking, what we need to do anytime we have a derivative problem is identify first which rules am I going to use, right? It's looking for, okay, how can I make this function fit in to the scope of my rules, which I know, right? And how do I identify which rule to use, and then how to identify making that rule work, okay? All right, let's learn a new rule. So last time we did this example from the start of section 3.3 where we did this sort of reverse composition problem, okay? I want to go back over that because this reverse composition problem process is super, super important when it comes to the chain rule, which is what we're going to learn today. So what do we want to do? For these problems, they tell us, well, we're going to give you like the answer to a composition function. And you have to come up with, okay, what then was the question, right? What then was the question? So I have two functions that got plugged into each other, and I got ln of 3t. What were the original functions, okay? What were the original functions? So for this example, we identified the inside function as 3t, which is being plugged in to the function ln of z. So that if I were to do f of g of t, that would be like doing f of 3t. And to do f of 3t, I put 3t wherever there is a z in f of z, and that would give me ln of 3t, right? So I think most people are confident going in this direction. When you have g of t and f of z, we had a problem on the exam that was to plug one function into another, right? But now what we're doing is we're saying, I'm giving you the answer to that problem, and you tell me the question, okay? You tell me what were the functions which you composed, okay? So for this other one, for example, 5 times 2t plus 3 squared. I think the inside function could be just whatever's inside the parentheses in this case, which is 2t plus 3. And that's being plugged into the function where you replace 2t plus 3 by a variable. So I like to use a different letter for the f function than I do for the g, just so that we don't get too confused. All right? So we're going to put in 2t plus 3 in for z, in 5z squared, and that would get us what we started with. Okay, that would get us what we started with. How do we feel about those questions? Like thumbs up, thumbs down? What do we feel fine with that? Okay, I see some thumbs sideways or down. So I know it's tricky at first, okay, but I promise with practice you will be flying through these with no problem. Okay, questions on that example before we learn the new rule? All right, so let's talk about the new rule then, which is called the chain rule, which is maybe the hardest rule that we're going to learn in terms of applications, okay? I think that the quotient rule maybe is harder to memorize, but the chain rule is the one that my students struggle with the most. So we're going to take our time here. So the question is, if I have a function f of g of x, how do I do the derivative of such a thing? Okay, how do I do the derivative of a composition of functions? So one function inside another function. So think stuff like this, right? 3x cubed minus x all being raised to the 5th. That's a function inside of another function, right? That's what we call a composition. Yeah.
Can't you just solve it out and then find the derivative of?
You could. You absolutely could. For this one, you could. Because you can just foil this out 5 times, and you'd end up with a polynomial, which you know how to do the derivative of all of the terms of a polynomial using the power rule. You absolutely could. But you probably wouldn't want to if I put a 50 there instead of a 5. It would take a really long time to foil 50 times. Okay? So that's why we like this rule, which allows us to sort of shortcut that method, okay? And it also allows us to do more complicated stuff, like you wouldn't be able to do that for something like this, right? Something like this, how are you gonna execute an x squared power on something, right? Okay, so let's get back to the rule. So we want to know how to do the derivative of one function inside of another function, okay? And to do that, we're going to have to be able to identify what are the inside and outside function, okay? That's why we did that practice, okay, at the start. But let's go to the rule, which says that this is going to be equal to the derivative of the outside function, where we leave the inside function alone, and then we're going to multiply by the derivative of the inside function. Okay, multiply by the derivative of the inside function. So sometimes I will say that we are, quote, chaining out, okay? This is why we call it the chain rule. I don't know, you could do this and then this. It's like, it makes some kind of chain picture or whatever. But the point is, this chains out, and we have to multiply by the derivative of the inside function. So the first step is to identify the inside and outside functions, do the derivative of the outside function, and just leave the inside completely alone. Okay, leave the inside completely alone. All right. So let's see. So I'm going to do like 4 examples, okay? And we'll start to see how this works. So in this case, for the first one, we've got e to the 15x. I could use the e to the kx rule if I wanted, or I could use the following. I could say f of z is e to the z, and g of x is 15x. Then if I plugged g into f, I would get what I have written here, okay? So I know that the derivative, okay, is going to be given by f prime of g of x multiplied by g prime of x. So to do this, to carry out this, I'm going to need 3 things. I need to know what is f prime, I need to know what is g, and I need to know what is g prime. I already know what is g, but I still need g prime and f prime. So let's figure out what those are. So f prime of z is just the derivative of this function, e to the z, which is just e to the z. And g prime of x is just the derivative of 15x, which what's that? Just 15. Derivative of a linear function is the slope. And now I'm going to just execute this by plugging g of x into f prime. So 15x needs to get plugged in for z in f prime, which gives me e to the 15x. But now I have to multiply times g prime of x, which is 15, so I get 15. All done. Okay. Sorry?
Where did the x form?
Where did the what?
Sorry, I should have supposed to. In the last line, e raised to 15 times x. I thought we got rid of the x.
So that comes from the fact that we're doing f prime of g of x. So what the formula tells us to do is to take g of x, which remember is 15x, and plug it in for z in f prime of z, right? So f prime of z is e to the z. We plugged 15x in for z. So that it's really just coming from the formula. The place where the x, quote unquote, went away was when we did the derivative of g. We got 15, right? So the derivative of g became 15, which is why there's no x here. There's no x here because we did the derivative on that part. So this part is where the x, quote unquote, went away. Does that make sense?
Makes a lot more sense.
Okay, good. Any other questions on that one? All right, I'm going to do like 2 more examples because I feel like this is the hardest rule to get down. So let's do this one. Well, this is my f of x, okay, and I want to identify the inside and the outside function, okay? So actually, why don't I change this and call this h of x, and I'm going to say h is a composition. It's f of g of x, right? So I need to figure out what's the inside and what's the outside. Well, a good rule of thumb for this type of problem is, look, whatever's on the inside of the parentheses, that's what is the, quote, inside function, okay? So in this case, the inside function, g of x, I would say is 3x cubed minus x. And if that's the inside function, what is it being plugged into? F of z should be what? Yeah, z to the fifth. Z to the fifth. So if I plugged in this thing for z, right, I would get back my original thing. So to do the derivative, h prime of x, I know I need f prime of g of x times g prime of x. To do that, I need to figure out what is f prime and what is g prime. So for g prime, I use the power rule. 9x squared minus 1. Okay, x becomes 1 because a linear function of just x has slope 1. Then f prime of z, power rule again, 5z to the fourth power. And now all I'm going to do is I'm going to use the formula, okay? So what am I supposed to do? I'm supposed to do g as the input in f prime. So here's g. I need to use it as the input in f prime, which is 5z to the fourth, okay? So I'm going to write 5, and then I put the input g in, which is 3x cubed minus x, and then raised to the fourth power. And now there's just one thing left to do, which is multiply, or if you want, you can visualize this as I'm going to chain out. I'm going to chain out the derivative of 3x cubed minus x, which is 9x squared minus 1, but I'm always going to plug with parentheses, right? So I should use parentheses so that I'm multiplying by all of g prime of x, not just the first part of it. Okay? Questions on this one? How do you know which, like, how do you know how to figure out what f and g are? Is that, yeah, that's the tricky part, okay? So there's a little bit of sort of leeway in choosing f and g, and we want to do it in the right way. Let me explain what I mean by the right way. I don't know how to just go ahead and straight do the derivative of h, right? It's too complicated. That function's too complicated for me. I want to come up with f and g in such a way that I know how to do their derivatives, right? I know how to do the derivative of 3x cubed minus x, and I know how to do the derivative of z to the fifth. So that's why I chose the functions in that way. Let me show you what I mean. I could have chosen them in a slightly different way. I could have said that, you know, g is 3x cubed and f is, no, I shouldn't have said that. I should have said, well, why don't I say f is 3x cubed minus 3. Oh, okay, how do I want to do this? Okay, I could have said that g is x cubed and f is 3z minus z to the 1/3 power, all raised to the 5th, right? If you plug g into f, you get back our original function. But this would be a really bad way of choosing your g and your f for the following reason. Yes, I know how to do the derivative of x cubed, but I do not have a flying clue of how to do the derivative of something like that, okay? So I want to choose the f and g with the knowledge that in the future I have to do their derivatives, right? So I want to choose them in the right way so that I know I'm going to be able to easily compute their derivatives. It's a really long-winded answer to your question, but does that give you a better idea?
Yeah, a little bit.
Okay. So in terms of actually identifying them, it's just something that takes practice. A good rule of thumb is g of x, your inside function, is just going to be whatever is inside the parentheses. In this case, 3x cubed minus x. Or sometimes it will be inside of the power, okay? What I mean by inside of the power is, look how we chose g for this one. I just chose it to be the power. So 9 times out of 10, your inside function g is just whatever is that power or whatever's inside of your parentheses, and then your f is just whatever is left over, okay? Does that help? A little bit? Again, it takes practice, okay? I know it's tough to visualize at first, okay? And there's a reason I said this is the hardest rule we're going to learn. So let's see some more practice, and maybe it'll start to become more clear. Yeah?
Why you did minus 1 instead of the x? It's not a constant function.
So when I did the derivative of g was 3x cubed minus x. So for the first term, I used the power rule. Became 9x squared. One power goes down by 1, multiply by the old power. For the x part, it's a linear function, okay? It's a linear function with slope 1. You could write it as 1 times x, right? The derivative of a linear function is just whatever is the slope, which in this case is 1, okay? Or if you want, you could think about it as using the power rule. X to the power 1, use the power rule. The 1 comes down, right? And we get 1 times x to the 1 minus 1 is 0, which is 1 times 1, which is 1. Okay? Two different ways of visualizing that. Does that answer your question? All right. Any more questions on these two examples before we move on to another couple examples, just so that we can really hammer this home? Okay, so let's see some more examples then. All right, so for part C, I have some sum and differences, and I can see that I'm going to need to use the chain rule specifically for this part. Okay, I'm definitely going to need to use the chain rule for that part. The other parts, I think I can just use the power rule and the constant rule. So let's start with tackling 5 times ln of 2t squared plus 2. Well, the first thing I know is that the 5 is going to hang out because it's a constant being multiplied by this function. And what I need to write in this blank now should be the derivative of ln of 2t squared plus 2, okay? ln of 2t squared plus 2. So in this case, my inside function is going to be what's inside the parentheses, so that's g of t. And then f of z is just whatever that function's being plugged into. So that function is the input in the function ln z. Okay, ln z. So what needs to go in this blank should be f prime of g of x, or sorry, g of t, times g prime of t. And then we are going to do plus 14t. So this is, I don't know, I call this h, and then we'll call this h prime of t equals to this. Okay, so I just need to plug in. So f prime of g. I know that f prime of z is 1 over z, because that's the derivative of the natural log function. And I know that g prime of t, that's the derivative of 2t squared plus 2, which is just 4t. So all together, I get 5, and then I need to plug g, regular g, into the derivative of f. So that gives me 1 over 2t squared plus 2. Multiply by, we have to chain out the derivative of the inside function, which is 4t. And then we add 14t, like so. So if you wanted to clean it up a little bit, you could combine some of this stuff into 20t. Actually, we could do 10t over t squared plus 1 plus 14t, if you wanted to simplify fully.
Why couldn't we include the 7t squared in the outside function?
Okay, so why isn't 7t squared part of f? Is that your question? Okay, so the reason is, if I then went to plug in 2t squared plus 2, I wouldn't get 7t squared. I would get 7 times 2t squared plus 2 squared. See what I mean?
I love the outside stuff.
You don't like the outside stuff? Is that what you said?
We just like this.
Okay, so the reason that I focused in on this pink part, right, is because the sum and difference rule says the derivative of a sum or difference is the sum or difference of the derivatives. So anytime you see a plus sign, okay, or a minus sign, distinguishing like separate functions, okay, all I'm going to do is I'm going to do each derivative individually and keep whatever plus or minus sign went in between. Okay? Keep whatever plus or minus sign went in between. Okay, the only reason I can't do that here is because this plus is inside of these parentheses, right? So I have to treat it as its own function, okay? Does that answer what you were asking? Okay. Any more questions on this one? The plus 14t came from 7t squared. And the 4t was g prime of t. It went in for the chain rule here, which got copied here. And then it went inside of the numerator. Okay, how do we feel about the chain rule so far? Do we hate the chain rule?
It's just like a lot to keep track of. It's like basic rules, but just.
Yeah, so, okay, let's talk quickly about how do I know when to use the chain rule, okay? The way that I identify when to use the chain rule is anytime I see a function inside of another function. Here's what I mean. You can see x squared plus 7 is in the power. That's a function which is inside of another function. Here, again, on this one, I can see I have the function 2x minus 1 inside of another function, okay? Or if I see this one, I see negative x squared as inside of another function. So that's when I know I need to use the chain rule. From then on, it's identifying your inside and your outside function and remembering the rule, which basically just says f prime g times g prime, okay? Should we do another practice, or okay, we'll do one more practice, and then I'm gonna give you a group exercise to work on, okay? Let's do this one. So we gotta use the sum and difference rule because I have a difference here. So I'm just gonna copy this minus sign down, and in each of these blanks, I'm gonna write the derivative of each of these two functions, okay? That's what that's what the sum and difference rule says I can do. So, first up comes the derivative of 2e to the x squared plus 7. Okay, 2e to the x squared plus 7. And I'm going to show you two ways of doing this. I'm going to show you the long way, where we go and identify f and g and do their derivatives and then use the formula. And then I'm going to show you what you're going to end up doing in practice later on once you know the chain rule better, okay? So first, the long way. We recognize that g, the inside function, is x squared plus 7. And the outside function, in this case, f, could be 2 times e to the z, okay? 2 times e to the z. So then g prime is just 2x, and f prime is just 2, hangs out, and e to the z's derivative is just e to the z. So now we need to do f prime of g times g prime, which is 2e to the x squared plus 7 times the derivative of x squared plus 7, which is 2x. Okay, so that's the long way, where we write all of this crap out. In principle, probably once you get a hang of the chain rule, you're going to see this and you're going to say, oh yeah, I know how to do the chain rule. The outside function's e to the z, and the inside function is e to the x squared. So the derivative of e to the z is just e to the z, so I'm just going to rewrite this whole thing, right? I'm just going to rewrite this whole thing, and then you are going to remember, and I'm doing the chain rule, so I have to chain out whatever is the derivative of that inside function, which is 2x. All done. Okay, that's probably what you'll do eventually, as opposed to writing all of this stuff out, because it's a little bit cumbersome to write. Okay, but I'm going to keep doing it for now. All right, how about the other one? What's the inside function? Good, 2x minus 1. And the outside function, then, should be 5 times what? ln of z. Good. So g prime is what? Just 2. And how about f prime? Uh-oh, do we remember the log rule? What is it? Yeah, 5 over z. Good. So now we need, again, to do f prime of g times g prime, which is 5 divided by 2x minus 1, and then you multiply by 2. Okay? So again, what you're going to notice after a while is like, oh yeah, every time I do a derivative of a log with something inside, I just write like, okay, in this case we have a 5, so the 5 hangs out, and then I just divide by whatever was inside. And then I multiply by the derivative of that thing, okay? This is how your brain will eventually sort of become accustomed to this process. But for now, if you want to write out g, f, g prime, f prime, and the formula, it's a surefire way to get the right answer. Yeah, Jake? I mean, you could simplify. If the problem says fully simplify, then you should write 4x e to the x squared plus 7 minus 10 over 2x minus 1. Okay. Any other questions? Yeah.
The previous example, you did 1 over z, and
Mhm.
but now we did 5 over z.
Yeah.
Why?
Because this is 5 times ln z. So to do its derivative, okay, to do the derivative of 5 times ln of z, the constant rule says you can take the constant out, right? And you get d dz ln of z, yes? You agree with me so far? And then, like you said, the derivative of ln z is 1 over z, right? So 5 times 1 over z. So if I have 5 times 1 over z, you just put 5 over 1, multiply the numerators together. That gives me 5. Multiply the denominators together. That gives me z. Okay? So that's just sort of under the hood. But that's what's going on. Does that answer your question?
No.
No?
So I mean, in the previous example, you did 1 over z.
Yeah, which example? This one?
Yeah. Why you didn't do 5 over z? did 1 over z.
Okay, yeah, it's just a matter of perspective. So in this case, I took the 5 out preemptively. But what you could have done is said f of z is 5 ln z if you want. That's
You
fine.
can't pull like 12 over z, right?
Yeah.
Okay.
But you could pull it out earlier if you felt like it.
So
These
it
rules
doesn't
can be applied in. Some of them can be exchanged in order. Okay, and that's one case where it can be
But in
exchanged.
that case, does that just like not matter? Because either way, the problem is like finished. Like, it's
Yeah,
fine
exactly.
outside.
Either way, you'll get the same answer. Is what I'm trying to say. Yeah, that's a good question. Any more questions on this one? Okay, then let's go to a group exercise. So this is a tough one, okay? But I want you to give it your best shot, remembering that the derivative, I'll write the rule up here, of f of g of x is f prime of g of x times g prime of x. But you're going to notice something with this problem. No formulas. No formulas. All right, but you can still do it using this equation here. So good luck. I'll be walking around. Jacob will be walking around to help as well. And just raise your hand if you have any questions.
Okay, so for the first one, like 1 to g of x. So you go to there, and g of x is 1, it's 7. So then you do f of 7, it's 8. The slope at 8 on f of x.
So if we want to know
That's the Does that make sense?
I mean, yeah, but like, why does that help us? Oh, because it's saying h of y. I'm actually so stupid. I was like trying to find out the equation.
Call that a day. It might not be right, but it's at least like kind of theoretical.
So if we want to do h prime of 1, we just need to put in a 1 and all the x's, right?
So you just did that. Plug 1 in and the outside was 7.
Yeah, you know what g of 1 is. Yeah, it's the height of the graph. When x is 1, which is 7. So this is f prime of 7 times prime 1. But what are those numbers? That's right, the slope. Yes, we can look at the slope of these lines. That will tell us what the value of the derivative is. So x is 7. Let's go to the picture of f. When
Wait,
x
what did you
is
get for the 7?
Negative 1.
horizontally, which means the
Oh,
value of x is 2.
right, I'm stupid. Yep.
So that number is
I was looking at the sum.
Yeah.
You said you got a fucking 4.
What was
That's where
g
you
prime
went
of
through.
g?
Oh. The slope of G-axis.
No, it's not.
Yeah, it is. It's going down to
Yeah, but it goes over two.
No.
Yeah.
No, it's going over. Oh, it is going over 2 because I from the bottom to go over 2, so I'm stupid.
I know what I'm doing.
Well, I know.
No.
So, we want to do.
I literally looked at down here and it's homework. It's around 1. I do meetings with my new project and I came here. And I'm going back to the library. I have so much shit to do, bro. It's so sad. I think the sports and team management, I'm just taking like V-Shades classes. I could I'll take 4 years off and then like like easy business because I thought health was gonna be the thing.
Just looking at you.
Everything else is killing me.
G of 1 is given by the height of the function, and the x value is 1, which is what?
I regret my real life decision. Taking calc, accounting, and professional communications all at once is like,
Yeah, G7, right? So we can replace
not
this
fun.
by f prime of 7
future dropout.
No, I really am so close to having a
And how about the other part? Now we got f prime. Is it gonna be the height?
It's not like spooky,
No,
it's like
it's
stuff like
already-
that, it's like honesty, whatever.
What, so the
It's
input is
like
what?
that. I don't care
Input
if I
7, so let's go to where x is 7. And then we go up to the function f is doing there. What's the slope of the function f?
This is so, yeah, dude, my friend, my friend gave her an hour talking about that. She found a shirt online and she's like, it says like, future trophy or something. And she's like,
So when
I'm
x
gonna
is
get
7,
this.
you
She's
go
like,
up
I'm
to
just like,
straight across, right? Straight across
drop out or some shit. And then I'm just gonna
So
like,
f prime of 7 is.
have my husband buy me a goatee online.
That's what I would do.
I'm so
How about you
frustrated.
run?
Okay. It's like, you do that, Caleb. The thing is like, dude, there's like just like no reason for me to be here. Like actually, like not even it's like the degree that I'm gonna get is Western retailing, like the digital creation,
Over 8 down.
I don't need that shit
So that's
at all.
negative 0 times negative
I'll get
1.
like snap pictures.
Yeah.
Yeah, my parents
Fucking dying. I don't think they'd care as much if it weren't for the fact that like they've already put a unholy amount of money into this year.
my education, my investment, my future.
Yeah.
Looks great.
Like I'm literally like not gonna use this shit. It's so sad.
Exactly. So this time.
It really is.
It's such a fucking waste of money.
I feel really guilty about it.
It's like it's just I don't know. I like find out so many ways to make money so easy. It's like,
I wish I could time travel. I just like go back in time and like give Steve Jobs like 500K. Okay, maybe not 500K. Would give him like some money.
if I like knew what I knew now about like ways to make money before college, I would have for sure like been able to argue my way out of like going to college at all. That's like I'm in too deep.
I wasn't having fun. I was
Not sure, right? Try the second one and see like I get a different number.
It's yeah, that is like the best way to describe it. Honestly,
naturally.
Maybe it's
it's
good
just so goofy, bro.
How tall is the graph, right?
I'm not built for that.
How steep the graph is. So if I look at the G function, right, the whole way it's the same steepness, and that steepness
What's up?
measured.
I gotta go take my phone to Verizon trained and even though I have a phone, I went and got this yesterday because during spring break my phone may or may not have broke. Yeah, I had my phone on Monday and Tuesday of spring break, and then I had my phone since
Got nothing.
yesterday.
Well, not nothing.
Yeah. I was like,
where are you running into trouble?
I was getting like
I have
screen
such a
time.
bad attachment.
Dude, no, I was getting like screen time every day. I'd like ask my friend Allison, I was like, please let me log on to Snapchat on your phone. Please. I was getting like 2 minutes of screen time.
Yeah, no, my phone, I'm emotionally attached to it.
It's just like, it's so convenient for like certain things. It's like, I wouldn't say that like I'm attached to like being chronically online, but it's like when I'm in the middle of like a place, like I'm in Naples, Florida, I've never been here, and I need to go find something, I can just pull it up on Facebook. It's like, that's inconvenient. But I can live without going like Snapchat.
If I know my phone is
I want to do H prime of 1, which I know H prime of X.
That's what I said. It's just like, or like
H prime
ordering
of 1,
food.
I just put
Like,
it
it's like,
every single daily age.
So H prime of 1
I can go to one restaurant.
can be given by F
So if you're staying at a
F
friend's
prime
beach house, her
of
mom
G
came there
of
for like 4
1
days, and the 4 days
times
that we
G
were
prime
there
of
every
1
single
agreed.
night for dinner.
Alright.
It was like a
G
fucking
of 1.
I had filet
Do I need to have the
mignon
formula?
for 2 weeks in a
Do you figure
row.
that out, or
You
can I use
know,
the
our
graph?
dinner
How about
on
use the
Thursday
graph?
night
Figure out what
was
G of 1 is.
250 CAD, so it was
Height
really
of the
like
graph when
230
X
It usually
USD.
goes
So
down, yeah.
So we can rewrite this equation.
Like I said, I need to make my
This is
list up
F
there.
prime of 7.
Yeah, when I go
times
back
G
home
prime
in the summer,
of
I
1
just
side degree.
yeah, it's just really fun. I think we're gonna be back in the summer too, so it'll be like really
I
fun.
want to go when it's like not
What is
where
G
it is.
prime?
Yeah, I was walking around downtown Toronto.
It tells you the
with
slope.
fields and things.
Which, what is the function
Like
of
an hour and a
G?
half.
Slope.
It's
It's
I was like
negative.
stepping from
So we put in
It's
negative
actually
1.
really fun while I was driving.
And we have to multiply that times F prime of 7, which is the slope of the F function when the X value is 7. What's the F function doing when X is 7?
Oh, dang.
It's going straight across, which the slope is 0 at that point. At some other points, it
Oh,
might
yeah,
be
so
something
that-
different,
so
like on the
when my
left,
phone
right?
broke as well,
But
I
at
cut
7, the slope is 0.
This is all
If it
cut
is
off. My
0
foot looks like a
times
fucking car.
negative 1,
Because when I fell in the water, my feet hit a bunch of barnacles and it just tore my foot apart, but it was red lines. So I got a bunch of bacteria shit. I go to the doctor the next day and I'm like, yeah, I think I need some antibiotics.
It's just
yeah,
telling you
you
that-
like might have a deadly fucking
Yeah, so it's not saying where in terms of the graph.
He's
It's
like,
saying
you literally can
it's
have
telling
like
you that
hepatitis
H of
A
X
dog. And I was
is
like, well,
a
you didn't have to say
composition
that.
of G plugged into
That was
that.
rude.
Right?
And so like
You
I
could make
couldn't
a
go in the
picture,
sun
by the way.
because I'm there, like,
H
it's
of
super
X.
strong and it would really make so like my skin
You
would
just
bubble
take,
if I got
okay,
sunburn
find
or
out what
sunburn.
H of 1 is
So, like,
by
then,
plugging
of
in
course, the
G
next
of 1,
day,
that gives you
I was
7,
like,
and then you plug in 7 into F, that would give you
So I'm just like sitting
8.
inside the house
Right?
like I like popped out to take like 2 pictures. And that's like it.
Okay.
I got so many friends. We went to Top Golf.
I love Top Golf. It's so good.
The closest one is probably Top Golf in Augusta. So it's like a small
Community
town.
house. Yeah.
But there's like 4 around us, I swear to God. But I was just like there. We were posted up.
I love Top Golf. Their food is so good.
Dude, the mac and cheese bites, those things, have you had those?
Oh my god, they're so good. So good.
That like sauce that they give you with them, that like tomato sauce is crazy. I always get them in that taco.
Yeah. So we want to figure out what H prime of 1 is, right? So H, they tell us, is F of G
These
of
kids
X.
on Craigslist,
So to find its
like,
derivative,
Brooklyn,
I know I'm going to need to use
and
that
they've been in Fort
formula
Lauderdale
there,
for
right?
2 weeks.
So you
Like,
agree
they were
with me
there all
that H
last
prime of X
My friend
is
is
given
in Fort
by
Lauderdale.
F prime of G of X times G prime of X. Yes. So in particular, if I want to do H prime of 1,
I had like so many friends like in
Okay.
Florida.
I'm just gonna plug
to
in once
visit,
for all these
but like
things.
I
Yeah.
couldn't just because like when I was driving through, it was too early where they live, and then like I'm so far like Naples is not near like anything
Yeah.
besides Fort
So,
Myers. And after that,
G of
you're in the middle
1.
of fucking nowhere.
Do you know how to figure out what G of 1 is from this picture?
Dude, the drive back was pretty good.
Yeah,
We left.
it's just the height of the function
Saturday
when the X value is 1.
nine.
Do I go to the G, that's the orange one, when X is is one, it looks like it's about 7 units tall.
It's so
I'm
demoralizing
gonna
driving
that by 7.
to like southern Florida because you drive for 5 hours and you're like, damn, I feel like I made progress, and then you look and you're still in Florida. And I'm like,
And now,
And then you're on 95, you're in traffic.
it doesn't tell me the height.
that's why we like when we left to go down to Florida, we left at 1 a.m.
Yeah, you look back
Prime
and
of
it's
seven
going
is
We
to.
left at 1
they're saying
a.m.
is like,
and we got there.
Go to the part of the graph that corresponds
like,
to x equals 7 for f. So that's
God, it was so weird because like so.
and you see where it's going down.
I didn't.
Eight.
I was like on the phone.
So
Like,
if I
it's like 5 a.m. I need
what is
gas.
the
It's
slope of
like,
the
alright.
function?
And then I'm like, alright, I'm turning around. There's this ice. And it's one for. I was like, there's gotta be gas stations in this
No.
Please, like,
And it doesn't really matter what there's like you're gonna fall into the air.
like all the gas stations are
That's the
fucking
slope
So if I have to drive
of the
and there's
current
a
line.
like a
So that
DSL,
one
which is $2,000.
when x is equal
Taking
to 1,
pictures
like,
like so the gas station.
you don't know how to figure that one out.
And I go into the top of the gas station and I'm not there. And like, you know that there's like a girl out there like taking pictures.
Well,
of all of us.
the
Like,
whole
yeah, they're not
green
like,
line
we
has the same slope.
Huh?
Yeah,
Like,
negative.
now I'm like related to Alex Murdaugh. Like, I was like,
Yeah, it goes over 8, down.
That is not every day you
Rise
I was
is
like,
negative
no.
8, and the run is
Actually,
Two?
I did
yeah, so
watch
that
the
gives us
I was like,
negative
no.
1 as its slope.
I was like, I need to get out of here, bro. I'm in the middle of nowhere. I got
Alright, so it comes down to the following. You gotta run it, and then plug it.
YouTube. For the YouTube. All right. So, what do we want to do here? So, h is just a function of x, right? So, you'll agree with me that h prime of x, since it's given by this composition, will be equal to, by the chain rule, f prime of g of x times g prime of x. Yes? And if we want to figure out what h prime of 1 is, all we have to do is put in 1 for x everywhere. So let's do that. Oops. G of 1 times g prime of 1. And then these are all able to be evaluated in the following way. G of 1 is just the height of the g function when x is equal to 1, which is 7. So I can rewrite this as f prime of 7. Oops. F prime of 7 times g prime of 1. And now this is the tricky part. We have to be able to know what these numbers are from the graph, which requires an understanding of what the derivative tells you about the graph. The derivative is the steepness of the graph. So f prime of 7 refers to the relative steepness of the function f near 7, near x equals to 7. Which tells us, well, the function's going straight across when x is equal to 7, which means it's constant, which means it's not changing, which means its slope is 0. So we get 0 times, and how about g prime of 1? That's the slope of the g function when x is equal to 1. Well, the slope of the g function is the same everywhere because it's just a line, and I can figure out its slope by doing rise over run. The way that I see it is, it looks like it goes down 8 and over 8. That's a slope of negative 1. So I get 0 times negative 1, which would be 0. Okay? So that's that one. Any questions? Yeah.
Since you got 0 in the first part, do you need the g prime?
You don't. No, because 0 times anything is always going to be 0. Okay, so one thing really quickly. I'm not going to go through this whole one. But just because we switch the letters, okay, doesn't really change much. All we're going to do is we're going to write g prime of f of x times f prime of x, okay? So it's not anything to do with the letters. It has to do with which one is the outside and which one is the inside, okay? All right, that's it for today. I can figure it out. Let's see, so g prime of f of 2 is 4, multiply with f prime of 2. F prime of 2 looks like it is 2, so that's 2, and then g prime of 4 is still negative 1. I think it should be negative 2.
Alright, thank you.
Right.